Hello everyone, welcome back to the world of STEM. Hope you all are doing well. I'm Steve Sajeev and today we'll be covering Java Arrays, which is Unit 6 of the AP Computer Science A curriculum. So first, why even use arrays? To see why, here's an example program. In this program, I stored the names of several cities using multiple string variables. However, as you can see, this gets very tedious as adding a new city requires me to create another variable. For example, I will add the city Houston to the list. Luckily, there's a solution to our issue, arrays. We can convert these multiple string variables into a single array, saving us time and effort and providing us with a cleaner solution. And I can add to this array easily by just adding a new item. We will see later how we can use this array to achieve the same results as the previous code, which used variables, but in a cleaner and faster way. Essentially, to manage large amounts of data or complex relationships in data, programmers write code that group the data together into a single data structure without creating individual variables for each value. The use of array objects allows multiple related items to be represented using a single variable. So how do you create an array? The basic syntax of an array is type, open square brackets, close square brackets, array name equals new type, open brackets, size, close brackets. So in this case, I created an int array named numbers with a size of 5. However, this type isn't only restricted to primitive types like I have chosen, but can also include reference types or objects. For example, if I create a class named cat, I could have an array of cat objects. Furthermore, once you have created an array with a size, you cannot change that size in the future. In this case, since I have made my numbers array with a size of 5, I cannot change that size in the future. When you first create an array, the elements of an array are initialized to a default value. For int arrays, all the elements are initialized to 0. For a double array, all the elements are initialized to 0.0. For a Boolean array, all the elements are initialized to false. And for an array with reference types, all the elements are initialized to null. However, we can change this by modifying the elements in the array. We can do this by using square brackets on the array with an index to modify an element located at that index. In this case, I've chosen to modify the element located at index 0 and set it equal to 2. Note that the indices of an array are 0 index, meaning that they start from 0, so the first element is accessed by the 0th index, and so on and so forth. In order to get the value located at an index in the array, we can use the same notation as before, with square brackets to get the element located at the index. To verify that I have changed the element at index 0 in the numbers array, I'll print out the value of the element at that index to the console. As you can see, I get the expected value of 2. However, what will happen if we try to access an element that is not within the array or if it's outside its bounds? For example, what happens if we try to access an element at index -1 or at index 5 of the number array, since the size of the array is 5? As you can see, when we run the program, we see that a runtime error of array index out of bounds exception is thrown. This is because the index we tried to access does not exist. In short, attempting to access an element that is not between 0 and the array length -1 will result in a runtime error being thrown. So how do you traverse an array? You traverse an array using loops, whether it is a while, for, or enhanced for loop. I will now demonstrate how to traverse an array using all of these methods to print all of the array's elements to the console. As you can see, running the code through each of these methods produces the same output. printing out all the elements in the array. Now, what are some applications? The first main application is called linear searching, where we search for an element in the array. If that element exists in the array, we return the index of that element. If not, we return -1. I will now create the code and demonstrate the output of running that program. As you can see, this code was able to determine successfully that the element Orlando existed in the array at index 0, and determine successfully that the element New Orleans did not exist in the array and return -1. This code can be modified to determine if at least one element has a particular property, the presence or absence of duplicate elements, the number of elements meeting specific criteria, and much more. Another application of loops is in calculating statistics of some data or values of an array. As you can see, using loops can help us analyze the statistics of an array as we can traverse through each element and perform calculations. For example, by comparing each element with the minimum and maximum value, we can determine the minimum and maximum value for the array, and we can calculate the sum by adding up all the values, and average by dividing by the number of values, and mode by keeping track of the count of each element in the array. Okay, so that will do it for the video. Thank you all for watching. If you have any questions, don't hesitate to put them in the comments box where we'll do our best to answer them. If you really loved it, make sure to subscribe, like, and share so that we can be a greater help to more people. This is Steve Sajeev with the World of STEM.